Our next session is the Sonex High Wing Update. And with us today is Mark Schabel he's the owner and president of Sonex Aircraft. He started with Sonex as an employee in 2003. He's enjoyed his time there so much that he became the owner in 2022. He's been generous enough to volunteer on the EA Safety Committee. He worked with us on the Sonex One Week Wonder in 2022 during AirVenture, where we built a Sonex in a week. And he's an EA member since 1994. Mark, thank you so much for joining us and giving us an update on what's going on over there at Sonex.
Thanks, Charlie, and happy Home Builders Week. I hope the week is going well for you so far. Can you see my screen?
Not yet. I think you still need to accept it.
There
There
we
you
go.
go. Looks
I
great.
accepted it, but there seemed to be a lag. So anyway, hello everyone, and thanks for joining us. And Charlie, I was going to have you switch my bio pic to this one yesterday, but I figured you were too busy with the rest of Home Builders Week. Just a fun little picture of me sticking my head out of the high wing.
And how
Looks
tall
fun.
are you, Mark?
How tall am I? Shorter every year, it
Are
seems.
you on your tiptoes in that photo, or is that your normal stance?
I don't remember. I think I was just standing normally. I'm 5'9". So yeah, you'll have to duck to get in. So thanks everyone for attending, especially with this webinar being during normal business hours. Good luck to those of you trying to do it incognito in your cubicle somewhere at work. We really appreciate you joining us. Just a reminder that you can find all of the other webinars that we've done through the years, not only on the eaa.org/webinars page in their archives, but we also do post links to those archives from our own website at sonexaircraft.com/webinars. For instance, you can see our Home Builders Week presentation from last year, which was more of a sort of an all-around orientation to our entire product line. So that would be a good one to watch if you're a bit unfamiliar with us. And our most recent webinar back on December 18th is available on our website and on EAA's archive, where we talked about an update for Rotax engine installations and Sonex aircraft, and a lot of exciting new information in that presentation. Want to thank the Sonex family, including our employees and our customers, of course, and our family members that support us as we do our work here at Sonex. Especially want to thank the staff that has really worked hard to help make the high wing a reality and continue to do great work every day here at Sonex. We were founded in 1998, so this is our 27th year as Sonex. Prior to that, John started in the late 60s, early 70s, John Monette, our founder, and you can see down there in the lower left a picture of him with the Sonorai 1 on the Sport Aviation magazine cover in 1972. If you're interested in learning more about John especially, and the early years of Sonex and the years leading up to Sonex, you can purchase his biography from our web store, John Monette from Sonorai to Sonex, up there in the upper right, and you will get a signed copy, signed by John. So at Sonex, we have three major product lines, and you can see the three logos there. Sonex Aircraft, of course, is the kit airplanes, and I'm not going to go through the entire lineup as we have a lot to cover today, and I want to make sure I leave time for questions, which I'm not always good at doing. But again, I would invite you to check out, obviously, our website and that webinar from Home Builders Week last year if you want an orientation to all of our different kit models. We also have the Aero Conversions product line, which includes the AeroV and the AeroV Turbo engines. Products like the Aero Injector, our brake system, our trim system, and lots of other neat accessories for experimental aircraft of all types. And then Sonex Aerospace is our product line where we work in the UAV industry. So some interesting stuff going on there. Not all of it can I talk about, but fun stuff there, really leveraging basically things based on our kit aircraft design for the UAV market. So Sonex High Wing is what we're here to talk about today, and I'm going to give just a real brief overview of what the airplane is and what it's intended. This will be a review for many of you, and then we'll get into some updated information. So people often ask me, I get this question all the time, why did Sonex decide to make a high wing? We only currently offer low wing aircraft. And although this project is my design, it's become my baby, the concept for it was floated, gosh, over 15 years ago now, hard to believe. And at the time, I bristled at the idea. I said, what do you mean? That's not what we do. But really, the more we discussed it, the more sense it made. You know, and you can see the bullet points there. You know, for us, from a marketing and market reach perspective, we've never served the high wing customer before. You know, there's that saying that you're either a high wing person or a low wing person. So, you know, that's at least half, if not more, of the flying public that we haven't appealed to previously. A lot of advantages too, and when it comes to ingress and egress in the airplane, you know, you hear a lot about the aging pilot population, and of course, I'm one of them. And not everyone wants to climb up on a wing anymore. So this is intended to be an airplane that's a lot easier to get in and out of, which I believe we have achieved. There's also some great opportunities out there for disabled pilots to start becoming pilots, including scholarship programs and things like disabled veterans and other opportunities. And so this is a great opportunity to serve them as well, especially those that want to do aerobatics. They can't do it in the aircraft that they're maybe flying currently. And also it's an opportunity to serve taller pilots. We've done some things to give you more room in the cockpit than our current lineup of airplanes, and just the nature of a high wing just squares off the ceiling area, the roof, if you will, of the cockpit. So it gives you more headroom just by the nature of it being a high wing. Also easier to provide more baggage space in the airplane. I'll talk more about that. Also, another reason for doing it is that most high wings on the market right now cater to the STOL crowd. And that's not what this airplane is really intended to do. So we're trying to fill a little bit of an open opportunity in the niche, in terms of the niche of high wing airplanes, for an airplane that is quick and aerobatic in terms of kit aircraft with decent cruise speed. And like I say, the next bullet point, not many aerobatic capable high wing aircraft, especially in the home built and light sport aircraft lineup. This is certainly represents a connection to the Sonex design heritage. And when I say that, I mean that, you know, if you look at the Sonex High Wing and the pictures and renderings, you'll see that the intent is for it to kind of be a metallized Whitman tailwind. And a lot of the Sonex's design heritage comes from Steve Whitman. Obviously, Steve was based here at Whitman Field in Oshkosh, and John Monette and Steve knew each other very well and had a great friendship. And some of the design attributes of the Sonex are design cues from the Whitman tailwind, the flat fuselage bottom, the curved airfoil shaped top of the fuselage, and some other things. So this continues in that tradition. And of course, it's the opportunity to do a high wing aircraft, quote unquote, the Sonex way, which is, you know, all about keeping things as simple as possible, including the construction of the airplane, sort of the box method of building the fuselage and the wings too. Everything in the airplane is basically a box with rounded parts on it. So here's just a nice CAD rendering out of our SolidWorks program of the high wing. We are, I will mention that we are, of course, offering a tricycle gear as well as tail dragger. And that first slide I showed that kind of had the 3-view diagram that showed renderings of a tri-gear and a tail dragger. The first prototype we are building is a tail dragger, and then once that's done and flying, we'll start building prototype number 2, which will be the tri-gear. So what are my design requirements? When I decided to do this airplane, I proclaimed, I guess, that it's not worth doing without these considerations. One is going to the LSA max gross weight, giving the airplane more useful load. So the intent was not to make the airplane heavy in terms of the empty weight, but to give it a higher gross weight while minimally increasing or keeping the empty weight as low as possible, and just giving more useful load. Now, of course, with Mosaic coming up, and I'll talk about that in a minute, there will not be a max gross weight anymore, but this is still very much part of the mission of the airplane. I wanted it to be a cantilever wing and highly aerobatic in terms of structural qualities of the airplane, just like everything else that we built. Wanted to retain Sonic's performance and handling qualities, and you can read and watch videos all about how a Sonex flies, which is pretty fantastic. And of course, we offer the best performance per dollar in terms of, that wide speed envelope of low stall speeds and very high cruise speeds in comparison. And, what does it cost you to build an airplane at a certain level of performance versus what you would spend to get the same performance elsewhere. As I mentioned before, easy ingress and egress, a door that exposes the footwell of the airplane, which you'll see in pictures and things in this presentation that we've successfully done. I wanted to offer center stick and dual stick options because that's one of those things that nobody seems to agree on. Everybody says that they want what you don't have. So we decided we're going to offer both right from the start. And then of course we wanted it to have a reasonable step in height. In other words, like all other Sonex airplanes, the intent was not to put it on an incredibly tall gear where you have to climb up into the airplane, even while it's still a high wing. And of course, I have to mention, going back to the stick options, that's an important consideration when it comes to getting in and out of the airplane, especially if you have some limited abilities. Wanted it to have good looks. Now, of course, looks are in the eye of the beholder, or beauty is in the eye of the beholder, and some people don't like how a Sonex looks. I think it's beautiful, especially when you look at the numbers. And I didn't want the high wing to be any exception to that. And you'll see in a couple of slides that the looks are, I think, really coming together and shaping up with some of the things that we have on the airplane since it was seen at AirVenture. One thing in particular, more cockpit space, as I talked about before, more baggage space, aux fuel options, which we have, BRS options, which we are working on and will be available, but it will still just be optional, and multiple purchase options. So we are, in addition to doing an amateur built kit, we will be doing ELSA and SLSA potentially in the future, meaning that we may be offering the aircraft once the new Mosaic rules come along, or Sport Pilot 2.0, we may be offering the aircraft as a turnkey production built SLSA aircraft. And then the other requirement is to be able to fit the finished aircraft in a shipping container. So whether we're selling quick build kits as amateur building kits, or whether we're selling finished airplanes, it doesn't make sense to have a ferry pilot to fly a light sport aircraft to other countries, to make it really difficult and arduous to be able to ship it, let alone put it on a trailer to get it from your garage to the airport. And so, like all of our other airplanes, the High Wing has removable wings, so you can do just that. All right, so specifications and performance, I'm not going to spend too much time on this. All of this is published on our website. I'll have the web address at the end of the presentation in terms of how to get to the Hornets Nest R&D area and look at all these specs. On the left there, you see tricycle gear shown in addition to the tail dragger that we're building right now. So, of course, 2 seats. Probably the most notable thing in this particular specs table is the fuel capacity. Currently in the B models of the Sonex YX Xenos, we carry 20 gallons. This will have the same 20-gallon tank, but it also has 10 gallons of aux fuel in the wings, in the inboard wing section, that you can just gravity feed right into the main tank. So in the utility category, here's the change that we've made over time as we've developed this airplane. We originally had this airplane targeted for a 1,320-pound gross weight, with Mosaic or Sport Pilot 2.0 making such significant progress, and with the release of the NPRM and some of the FAA's favorable responses, unofficial responses to some of the comments that came in during the comment period, I figured it was safe and would be desirable to take advantage of the new rule. So we did put a little bit more structure into the airplane. That of course did impact empty weight a little bit, but we're making the max gross weight 1,500 pounds. So you should be able to have a ton of useful load if we're successful in keeping the empty weight down around 800 to 820 pounds, which so far we're very much on track for. And you can see there max baggage of 90 pounds. That works out with weight and balance studies that we've done. Of course, you know, it depends on how you have the airplane loaded in terms of passengers and fuel. But there are scenarios that allow you to do 90 pounds of baggage if you want, or, you know, a 40-pound BRS system and still have some capacity left over for baggage. Now, when we talk about aerobatics, this is the first airplane that Sonex is offering that will be approved in the aerobatic category with 2 people on board. So all of the existing airplanes that we offer are utility category when flown with 2 people on board, above 950 pounds essentially for the Sonex and YX, and are aerobatic when you fly them solo, and of course within the more limited CG range that we limit aerobatics to. So for the High Wing, especially if it's going to be built, and I say if, but we'd like to do it as a production airplane, as an SLSA, we wanted the airplane to be able to do aerobatics with 2 people, maybe serve a niche in terms of new aircraft availability in the training market, or something that flight schools can use, you know, to basically train pilots all the way up to CFI, including their spin training. And so this airplane can do aerobatics with 2 people. We do have, we'll have 2 different wingtip options, and you can refer to our earlier webinars and updates to get more details about this. But basically for 2-place aerobatics, you're going to take our longer fiberglass wingtips, which are about 1.5 feet long each, actually less than that, and replace them with just some end plates that we'll have, which just goes on easily with piano hinge. You can just pull the hinge pin with a pair of pliers and swap out the wingtips in a couple of minutes. Really easy to do. But you can see here basically aerobatics to 6 Gs at 1,230 pounds. Which, you know, you have to definitely be, you know, if the airplane is weighing 800 pounds, you have to, you know, load it a little more carefully there. Or like some of the American Champion aircraft do, we have what we call a limited, not to say that, you know, we're approving unlimited aerobatics as you would hear of it in aerobatic competition, but limited aerobatic approval up to 5.5 Gs at 1,340 pounds. So that is what all of our all of our structural studies and our weight and balance studies to date have shown that we'll be able to do. And of course, we'll prove that out through the prototype and what it actually weighs and what the CG actually is. And of course, our load testing that we'll be doing on the static load testing that we'll be doing on wing and tail samples. Just some size comparisons here of this high wing versus a Sonex. And I'll just note right away on the picture on the left, if you look at the high wing, you'll see a little break there, a little vertical line at the wingtip. That's the fiberglass wingtip shown when I'm talking about a wingtip that you can easily remove and replace it with an end plate. And again, that'll be necessary for two-place aerobatics. Just because what that does is it reduces the moment arm at the tip of the wing. It reduces the bending moment in terms of what the wing has to be subjected to for G-loading. So it keeps it within the capabilities of the structure. We do have a 2-inch wider cockpit, so the interior width of the inside of the high wing at the shoulders is 42 inches. The wingspan, of course, at its full span is 4.2 feet longer. We're 14.5 inches longer in length than the Sonex. And I'm sorry if I'm stumbling a little bit here. I have some webinar windows. I'm going to try to minimize these so I can actually read my captions better. Bear with me. Just can't read all my captions. There we go. Let me go back to that previous slide. Yeah, 14.5 inches longer. Now I can read it. All right, and here's a cockpit comparison. And of course, we have our friend CADman in green. And you'll see that in the high wing. As I mentioned, it just being a high wing, the curved canopy can be a bit more restrictive in a low wing airplane versus the rectangular cabin in a high wing airplane. So that gives you a lot more headroom. We've been able to get the seat a little bit lower to the belly, which helps in terms of the amount of space that you have. Also, due to the layout of the aircraft and the longer tail and everything, the CG characteristics of the airplane, we've been able to move the wing and the pilot's seat approximately 2 inches further aft than the Sonex. So that gives you a little bit more leg room as well. And then engine options, we have our regular stable of engine options that you'll see, and you'll see we're doing a UL power installation on this first prototype. So we have the AeroV Turbo, UL Power, 4-cylinder engines, Jabiru 3300, or any Rotax, I'll say any Rotax 9 series engine. We'll see when it comes to things like the 916. I'm sure somebody will do it. It's going to be way more power than the airframe needs. When it comes to the AeroV and its 80 horsepower configuration, we're not 100% sure how that's going to fly yet. What we're basically going to be doing in test flight of this first prototype is graphing out RPM ranges agreed upon between UL Power and Sensonic, who makes our propellers, and chart out what RPMs on the 130 horsepower UL Power engine will best simulate these lower horsepower levels. So we'll test at 80 horsepower, we'll test at 100 horsepower in terms of climb performance I'm speaking of. And we'll see, just make sure that we feel that we have adequate climb performance at 80 horsepower. I'm confident that anything 100 horse and over will be just great in the airplane. So at Oshkosh, if you were lucky enough to attend AirVenture this year, hopefully you saw the high wing prototype. And this is not just a mock-up. This is the #1 prototype that we are still working to complete and get flying. And you can see it there looking great in our booth. And on the left, you can see a corn-fed son of America there sitting with his dad, kind of a big guy. And we sat, I couldn't even tell you how many people. I would say it's in the hundreds of people that tried on the high wing of all shapes and sizes and all abilities in terms of mobility. And it was a great proving ground for everything that we wanted to do with the cockpit. And I would say, it's done done everything that we want in terms of that. You can see there the little 3D printed duck hanging from the inboard wing. It's a little hard to see when you don't have the full wing there, especially when you're getting out of the airplane, that, oh yeah, it's a high wing. You gotta, and it is a small airplane, and yeah, you need to duck. So we put those on there as a reminder. So here we have a couple of examples sort of at each end of the spectrum in terms of pilot size. On the right, we have Paul Dye, who's not the tallest individual. I'm 5'9". I think he's shorter than me, if I'm not mistaken. And you can see he's got just tons of room and in the airplane, and still liked how it fit. And then on the left here, we have James from our staff. He is, as he says, 6'4" without shoes on. And he's shown here sitting, we had some pretty thick cushions that we got for this, kind of more as an eye for comfort for us flying the airplane. And we're not really big people, most of us here. So the cushion that he's sitting in right now has a 3-inch thick lumbar support in it. So he would have even more leg room with just a traditional cushion on the seat back. So, and he fit just fine. And then here's a couple more pictures. You know, for people maybe a little shorter than Paul, if you look in the bottom part of the picture and the lower and the left-hand side picture, you'll see that the seat back folds and you get a great look at the pretty large baggage compartment. But there in that detail picture on the bottom, we actually have two positions in which you can put the seat back and the hinging portion. And so we have a, it's hard to see in the picture there, but it's just a, you know, quick release pin with the spring loaded ball on it for a retainer. You know, just with a little keychain loop on it, the part you can't see on the other side of the aluminum there. So it's easy to just pull that pin out, and there's a permanent pin on the other side of the seat that easily comes out of the slot, and you can move the seat 2 inches further forward, and that's what that front hole is there. So if you're a bit smaller, you can still you know, be able to be in this airplane and, you know, see over the instrument panel and be able to reach the rudder pedals. And we haven't built them yet, but we'll have the support on the seat back that braces to the cross tie so that you can vary the angle of the seat back, especially when you're in that front seat position hole. And then on the right there, you can see Tony on the right and Chris on the left from our shop. Now, these are not the biggest guys either, and admittedly, they are both holding their inboard arms as if they're holding control sticks. So, you know, you can see they're honestly not touching shoulders in the airplanes, nor are they sticking out the door. They're well within the airplane and not touching shoulders. So very roomy inside with that extra 2 inches of width. And then here's a good look at the skylights. Not many people realize when they look at pictures and renderings that we will have skylight windows. You can see there's in the right-hand picture that there's a window above the baggage compartment that's quite large, and you know, that combined with the rear windows is really great sight lines for scanning for traffic. And then you have the skylights above you that you can see there on the left and in the right picture. So pretty good visibility, even considering the way that we've done it as a cantilevered wing, which needs a substantial spar that you can see there, and the way we're doing the windshield with the leading edge of that center section wing. You can see in the right-hand picture too the seams, if you will, for the covers that go on the aux tanks in the wings, and there will be doors on those to access and fuel those. We just haven't gotten there yet. All right, so let's get to some progress here. So here's some pictures. I'm just going to be showing you what we've been able to accomplish since AirVenture. Admittedly, you know, at first blush, you know, to me, I get a little bit nervous about giving a presentation like this because it doesn't look like a lot, but there is a lot happening and there's a lot that we have done, and we are getting ever closer to finishing this prototype. We are working really hard to be able to fly this thing, hopefully in March or April. And I feel that we're on track to get there. So we'll see how it goes. But you can see there, I put this picture on the right on the website as the preview for signing up for this webinar. We had some fun with people on social media, people commenting about the windshield, quote unquote. And, of course, this is just a mock-up. You see me sitting in the airplane there on the left, and we made a lot of Charles Lindbergh jokes when we had this mock-up on the airplane, and got a guy here that does a great Jimmy Stewart impression, so that was fun. And but basically, the point of this is to finalize the windshield shape. It's hard when you go from a CAD drawing to the physical world to finalize a shape like this and get the trim line just right. We wanted to establish the shape and determine what the tooling is going to need to be to make that windshield, which we are working on. And you can see there we've got doors. So the door that you see there now was kind of I'll call it a test dummy door. So we built one door with the bracing on the interior structure that we felt that we would need, and we modified it along the way just to get the rigidity that we wanted out of the door structure. You can see obviously in orange there we have 3D printed hinges, and that was also an iterative process to finalize the hinge shape and structure, and those are being ready to be CNC machined out of aluminum, of course, just to be able to operate the door and make sure that everything is functioning the way that we want it to. The hinges, you can see that detail picture on the lower right. Now, before all you A&Ps comment about the horrible rivets there, those are just temp rivets. They are just temporary aluminum rivets. They're not even up drilled to full size. They're 3/32, which we use a lot when it's sometimes when Clecos get in the way of like trying out a door hinge, for example. We use these temporary rivets. So please don't pay attention to the workmanship there. But the point is, this is a picture from the inside of the fuselage. And so the hinges actually pin on the interior of the airplane. And so that's really important for the aerobatic mission. Of course, two-place aerobatics, the occupants have to be wearing a parachute. So you need jettisonable doors. On a low-wing airplane, it's not a big deal. You just unlatch the canopy, and the canopy departs the airplane right quick. But in this case, where you have a door that's hinged forward, you need to be able to disconnect those hinges so that the door can depart the aircraft safely and you can get out. So the pins on the inside, will have basically a simple cable release. There'll be basically a handle that you will pull, and you'll be able to pull those pins out and push the door out. And you won't even have to do anything with the actual door latch. You'll just be able to push it out into the airstream and the door will be gone. Also, a nice thing about this hinge design, it's hard to see in this picture when you look at those 3D printed, those orange hinges. There's an angle there at the leading edge. It fills up that little hole that you see in the detail picture to the outside, fills it up quite nicely, so it shouldn't be too drafty. You can certainly cover it if you want on the inside. And the hinge itself, that orange piece, actually creates the door stop. So it stops against that interior piece that's attached to the fuselage when it swings open. So you don't need like a lanyard stop, which of course is important. Again, if you need to have jettisonable doors, you don't want a lanyard for a door stop that's there, preventing the door from leaving the airplane. The other thing I'll mention on this slide too, and this is kind of what I was talking about in the beginning about the airplane looking good. I think at AirVenture it was kind of deceiving, and even looking at our CAD models, it's deceiving, the looks of the airplane, the aesthetics. But in that picture on the left, and not because I'm sitting in the airplane, but the picture on the left really shows what an attractive looking shape this airplane will have, at least in my opinion. If you look at the shape of that windshield and that, retaining the streamlined properties of how we shape the Sonex, it just, I think it's going to be a really good looking airplane when it's done. I'm really excited about it. Here's some details about the door. So just as far as a door handle on the inside, just a real simple piece of webbing for the handle. That way, your shoulder can, brush up against it and you don't even know it's there. And it's convenient to grab it and close the door. And then the door latch itself. So you can see it's a nice little plastic, impact resistant plastic assembly. It's actually made by Southco, which many of you may be familiar of. They make, a lot of the quarter turn fasteners and other things that we use on airplanes commonly. And they make this door handle. Nice thing about it, it's super lightweight. It's flush, as you can see, when it's closed, so it's very low drag on the airplane. It's got two what they call latches, what they in the industry, as I've learned, they call it a pawl, a P-A-W-L. Anyway, the pieces that stick out the sides that actually catch the striker and hold the door closed. So it has two of them, and they're spring loaded to be, closed. And what we can do, I don't have a good picture of it here, but if you look at the picture on the left of the door handle, you'll see below it in the interior door structure a really small, just a 16th inch diameter steel cable. And so we can attach a cable to the pawl, to the latch, and we'll be able to have probably another piece of webbing that's just sticking out of the trim panel that we'll have on the interior of the door to make it look nice. And you'll just be able to pull that handle or pull that piece of webbing and be able to unlatch the door very easily. And it's super lightweight and very simple. We are, as you can see, mounting these, or maybe you can see, you'll notice if you look at the lock symbols, yes, we're mounting it upside down. And we decided to do that for a couple of reasons. One, we feel it's a lot more ergonomic that way. You can see the picture on the right where you just basically, push your thumb into that little dimple to expose or start to pry open the latch, and then your finger, just with your hand in a normal upright orientation, can grasp it and open it. We tried it the other way, and it's just kind of awkward. You kind of have to do it in a weird upside down way, such that I think anyone with, again, aging pilot population, right, or just people with disabilities, it can be difficult to actually open the door. The other thing that we really liked about mounting it upside down is just the way that the housing, the plastic assembly is built. The bottom of the inside behind the paddle of the latch is totally sealed up. So if the airplane's out in the rain, any rain that happens to get in through the seams of the paddle latch will just drain right out. If we had mounted it the other way, that moisture would be draining into the interior of the door. And of course, if you have like an upholstery panel on the inside of the door, it's going to trap moisture and corrosion and all that bad stuff. So it's just a better drainage, if you will, consideration. So going back to the windshield, we had to modify some of our tooling for how we make canopies to make this windshield. And so you'll see there in the picture on the left, in the back there, the thing on wheels, that's our canopy oven that we put the big sheets of flat plexiglass in and we heat them up. And then for our canopies, we take them out of the oven and we blow a bubble with compressed air. So what we built is, because this windshield basically doesn't get blown into a bubble or stretch formed or anything like that, it's just a flat wrap. So it's just needs to be heated up and drape formed. So we can't clamp the plexiglass into a frame like we normally do. So what you see on the top of that oven in black, that's basically just a shelf, and the shelf has a welding blanket on it. So a nice felt blanket that won't abrade the plexiglass and is obviously highly temperature rated and fire resistant. And it's hard to see in the picture, but there are gaps all around that shelf so that heat can convect around it. And then we built a lid for the oven. there on the left, you can see it on the floor, and the picture in the middle there, you can see it actually on the oven. So of course, and it's insulated and has handles, so we can easily lift it on and off the oven. Of course, I built this thing and I took a picture right away and sent it to Paul Dye at Kit Planes, who of course is, you know, ex-NASA. And I joked, this is our entry into commercial space flight. I don't know if he didn't find it funny. I didn't get a response, but I thought it was pretty hilarious. Anyway, so that's how we're going to make the windshield. We've done a few test pieces. We have a little bit more tooling to make in terms of the former that will actually drape form it on. And it'll essentially be like the windshield mock-up that you see in the picture there, just has to be smaller for the thickness of the plexiglass and also the thickness of the felt that we'll have on it. It'll be covered in felt, again, to help prevent the glass from getting scratched when we're forming it. And so we've done some tests of some scraps of plexiglass using just forming it around that windshield mock-up that we already have built, just to test the curve in the corner of the windshield, because we wanted to make sure that it was nice and clear optically, that the curve didn't cause distortions. And we're happy to report it doesn't. It's really great. You can look through it if you're, you know, in the traffic pattern and looking for traffic, or looking, you know, from base to final at the end of the runway. There are no big distortions. It's actually better than like a Cessna 172 windshield, in our opinion. So it's going to be a really nice windshield to look through. All right, so one of the things that we've been talking about from the beginning here is the control sticks. And as I mentioned before, one of my design criteria was to offer both center stick and dual stick, and make it easily convertible. So as I mentioned in previous updates and webinars, we have a stick frame in front of the seats. And that you know, has basically 3 stick receptacles, one between the left seat's legs, the one between the right seat's legs, and one in the center column. And you can see in the CAD renderings on the left there, you know, lots of people love the traditional dual sticks. Of course, we want to offer that. But that center stick, especially if you have mobility issues, is super easy for getting in and out of the airplane. So you just can't, you know, we can't not offer that because it's such a great feature. So on the right there, we've changed a little bit how we originally thought that we were going to attach the sticks. We had an original concept. You can kind of see remnants there of it in that weldment that you see in the 2 pictures. You see that little U-shaped cutout. That was supposed to be for an alignment pin. We built it and just decided it had way too much free play, and just wasn't going to work. It wasn't going to be a safe system for, you know, anti-flutter and things like that. So we changed directions, and you can see what we have here. We have a simple aluminum, I'll call it a drogue or probe, if you, I was thinking probe and drogue, like aero refueling, but we have a simple aluminum probe, and we have a stainless steel receptacle. And this is a stainless steel, actually it's a wiring component that you can get off of Amazon. And you can see that nut there on the top part, the part that's attached to the control stick. It's a lot like a Canon plug, but we're not, yeah, there's too much going on. It's going to be too difficult and too expensive, frankly, to offer a Canon plug for electrical hookup. You'll probably just have a quick disconnect wire for your comm switch and maybe your trim or something like that, if you're doing electric trim. But anyway, this has basically a tapered receptacle on the inside. You can see the taper on the probe end, the aluminum end, where you see the stick disconnected. The nut there, what we did was we put a large O-ring on the inside, and you can't see it, but it's oh, I don't know how many millimeters thick it is, but it's thick. And so what that allows us to do is all you have to do is hand tighten that nut, and you take all the free play out of the stick, and you have a really great installation. And you could still easily loosen it by hand and quickly remove the stick. Now we're doing some things to refine it right now. You can't see it well in the picture. There's a slot in the front of that aluminum piece and just a very small indexing pin. We didn't really like how that worked. What we're going to do is a a pin that goes across the bottom of it, and it'll be a slot. And so the indexing, of course, is important to making sure, of course, that the stick is oriented properly and stays put and won't rotate. So this is kind of a neat thing that we're excited to finalize and get into the prototype here soon. And some more progress here. We've got some more of the control system done. So on the left there, you can see basically the aileron and elevator layout diagram. As I've covered in previous presentations and updates, so basically the sticks will be tied into a torque tube in the center console, and there'll be a push rod, vertical push rod behind the aft wall of the baggage compartment, and then there's a top torque tube that goes to the aileron, goes out to the ailerons. So it's a nice way to do it. Of course, we wanted to stick with all push rod connections like we've always done, especially for an aerobatic airplane, again, avoiding possibility of flutter and free play in the system. Now, we've done something that we're so far extremely happy with. Instead of having traditional pillow blocks for these two torque tubes we have in the aileron system, we're actually just using bolts and bronze bushings at the end of each torque tube. So that well, you can see it there in that middle picture on the right-hand side of the picture at the front of that torque tube. That works extremely well. It makes for a system that's extremely light and loose, and while still very tight in terms of not having free play. And you can see on the picture there on the right, sort of the ceiling or above the ceiling of the cockpit. We don't have that center wing skin final riveted yet. The connection from that front torque tube's bell crank out to the push rods that'll go out to the bell cranks in the wings. And you can see we've got aluminum push rods there. So, of course, all of the control forces and all the torque conversions were analyzed to be able to build the system as lightweight as possible, but with, of course, the appropriate strength against buckling of the control surfaces. Now, I will talk about torque tubes just real briefly here. We generally don't like torque tubes in aileron systems the way that we've traditionally seen them applied, where torque tubes, can have a spring effect in a flutter situation. This avoids that because you could see in that picture on the right, the two ailerons are directly connected to one another. So we don't end up with that wind up of the spring effect in a flutter type situation. And of course, we have a lot of other flutter mitigating design features, such as the counterweights in the ailerons, the blunted trailing edges on all of our control surfaces, just the flat shape of our control surfaces. Lots of things there in the design that we've always had that are anti-flutter techniques that have worked for us tremendously well through the years, even on things like the Subsonics jet, where we're flying very fast. And rudder cables. We have rudder cables in the airplane. And as you can see here, the rudder cables, what you're seeing is the center tunnel. Now, the sort of open bracketry that you see there on the right-hand side of the picture is where the stick frame mounts, and there's a cover that goes over it. It's basically at the very front of the seat, sort of under your, under your knees. And so the torque tube for the aileron, the push rod for the elevator, and the rudder cables all go through, the center tunnel. And traditionally what we've done is the rudder cables have gone down the fuselage sidewalls and attached to the rudder pedals on the outboard extremes of the rudder pedals. And in doing that, you've got the right rudder cable attached to the extreme right rudder pedal and the left rudder cable attached to the extreme left rudder pedal. In this case, we're attaching the rudder cables to the two inboard rudder pedals. In other words, the pilot side's right rudder and the passenger side's left rudder. And bear with me here, a little bit of a thought exercise. In that situation, the rudder cables have to cross each other in the fuselage to not be reversed. So one of the things that we wanted to do in this airplane, because although we have covers that are removable, we wanted to reduce, of course, the complexity and the expense of the aircraft. And phenolic pulleys from aircraft sprues are very expensive, so we wanted to avoid those wherever we could. So we tested an idea to basically have fuel line tubing, sections of fuel line tubing, with nylon tubing inside of it that the cable can run through. We don't have any sharp bends here. We have no 90-degree bends or anything like that in the cable path. So all of these very gentle bends can easily be handled by this tubing and just simple clamps. So that works really well for us. And since we had the nylon tubing and since the cables have to cross in the fuselage, we decided to color code them. So the green it means right rudder. And you'll see we're kind of looking down with the seats on the right and the firewall on the left, the green cables on the left, which is counterintuitive. So we felt it was very important from a safety perspective to color code them so that you're installing them properly on the correct side. Those will all be provided pre-swaged and with the tubing and everything in the kit when we ship them. So kind of a neat idea. You see, I have a note there. Are you ready to have your mind blown? So if you know Sonex, this might blow your mind. There it is. So we've always very strenuously resisted toe brakes. So if you know anything about Sonex and our design philosophy, we've always avoided it and recommended against it. And there's reasons for that. We have direct steering, so we don't steer with brakes traditionally. We have a direct push rod to our tail wheel, no springs in the system, makes for a much easier tail wheel system to handle. And in our tri-gears, we have steerable nose gears. And we still have that. We have not changed that. But with this high wing design, with the big doors and wanting to have the two different stick options, dual throttles is something we can easily work out and make work. But what we were having trouble with is what was kind of blowing our minds in terms of doing it in a quality way. We looked at a few different concepts. It was how to have our traditional hand lever, brake lever, and not have it just get in the way or be really awkward or be, like a torque tube system that's really heavy. Knowing that people through the years, we do things a very special way, unique way at Sonex to be true to the mission of the airplane. It's not always what the builder wants necessarily. So people through the years have done their own toe brake installations on Sonexes. As you can see, the rudder pedals hang down from the top, just like a Vans RV. Doing a toe brake is not difficult to do. So we decided, why don't we just bite the bullet and try out a toe brake system. Now, of course, this is just a tryout for this prototype. I can't guarantee that we're going to like it or that it's going to make its way into the final kit. Again, if you're a builder and you insist on having toe brakes, people have done it, you can do it. But my concept here is that, okay, the little master cylinders from Matco are really lightweight, so no real big weight penalty there to do toe brakes versus our single lever brake. Our single lever master cylinder is, not as exceptionally light. You have to put a big handle on it to get enough mechanical advantage. So, apples to apples, we're not talking about a big difference in weight here. What I didn't want to do is spend twice the amount of money on 4 master cylinders to have braking on both sides. So we came up with this idea of just having a cable actuated passenger side brakes, or instructor side, if you will. And so we've mocked this up. You can see in some of the detail pictures there up in the middle and the top, the cable. Now, again, A&Ps in the group, don't send me emails. Yes, we're going to put a proper cable guard on there so the cable can't jump off the pulley. We just haven't done it yet. And of course, that's all temporary hardware, so don't get on us about cotter pins and all that sort of stuff. But this is a mock-up. You can see we have to repaint the rudder pedals, and it's working really well. The slaved, if you will, passenger side rudder pedals are actuating the brakes perfectly. And you know, the cable, that 16th galvanized cable, is more than strong enough to handle the load. Keep in mind, we had cable actuated drum brakes in our airplanes for many years before we ever did hydraulic brakes. So this is an innovative idea that, you know, I'm pretty proud of so far. Seems to be working. It's going to blow some people's minds, and may be some people who are really hardcore Sonex traditionalists, maybe the founder of the company that might groan a little bit, but hey, we're giving it a try. We're trying to give people more of what they want. Like I said, I can't guarantee it'll end up in the final kit, but so far it's looking good. Really liking it. All right, outboard wings, those are in progress as well. You can see there we have both of the outboard wing spars riveted. You know, again, if you're not super familiar with Sonex, the wing spars are really the only part of the airplane that has solid riveting for the builder, and we provide the wings pre-riveted, or the spars pre-riveted, for all of our kits. So you really don't have to do any solid riveting. It's all stainless steel blind rivets for the rest of the project. But we do have the outboard spars riveted here for the prototype, and you can see the sort of the test fit there on the left. On the right, you know, we do a lot of 3D printing, especially, you know, we really started with this aircraft development program. Anything from, you know, hydroform, you know, rib press tools, or you can see a great example there, the orange little smudge that you see there in the right-hand picture on the bottom by the seat. That's actually the catch for the door latch, and that's working really well. Of course, we won't make it orange, we'll make it black or something, but yeah, 3D printing was great, and it's surface mount. You don't even have to cut a hole in the door jamb. But what you see there in black is a 3D printed, just basically a test fit mock-up. You can see it's long. We had to print it in two pieces and glue it together. You can kind of see the glue there on the seam of our wing attached ties. And again, if you've looked at our previous presentations, or you're familiar with aircraft like the Subsonics, you can see, you know, that we have strain matching structural ties to attach the outboard to the inboard wing when we do center section wings like this. And they have great structural performance. All those steps that you see there are the different bolt locations. And again, there are different thicknesses to ensure that all of the bolts are loaded evenly. And what it avoids is you know, failing the first bolt in line and then the next one in line, and it just all the bolts break like a zipper. So this is very important for joining a wing like this. So just a fit check there on that, kind of a geeky engineering side note there in terms of the wing ties and how they work. And then, so you can see on the left there, and this picture was actually taken this week. We're got all the ribs done and the rear spars, and of course the main spars have been done for a while, and we're framing out the outboard wings. And you can see there we did another test fit there. You kind of get an idea of the wingspan there on one side, and we'll be starting to skin the outboard wings here in the next couple of weeks. So really exciting stuff there. Then the tail tips, I mean, just a minor item, but you know, it's significant milestone. The tail looks right now versus the way you saw it at AirVenture. And you'll see there on the right another 3D printed piece. So as I mentioned, I think in a previous update, we 3D printed the tail tips, not just to check the fit, but we actually had our fiberglass vendor make the tooling, make the mold from these 3D printed plugs. And as a result, these tail tips have installed on this high wing prototype easier than any tail tips we've ever had before. So I think that's going to be a really benefit to making the kit even easier to build. Engine installation has begun. So the engine's been hung on the firewall for a while now, just sitting there, not doing anything but being a counterweight. But in the last few weeks, we've started actually hanging items on the firewall. Of course, we're using the UL350 IS on this airplane as a prototype, and thanks to UL Power for all the great support that they've given us for this. And you can see in the picture on the right, and actually on the left as well, we've got things going on the firewall. You can see the battery box there. In the picture on the right in the middle of the firewall, you can see the fuel pump assembly. Next to that, you'll see a bracket that will hold the fine filter for the fuel injected system. And on the far right there, you see the ignition coils. You'll notice there below the top ignition coil, a stiffener for the firewall. We've kind of, I'll admit, unstrategically have added stiffeners on the firewall as we've mounted these components. We're gonna, for the next prototype and obviously for kits and installation packages, we'll be more strategic about where these stiffeners are located, for the final package. And on the back side of the firewall in the left there, you can see the ECUs. We are doing the ASTM compliant version of the engine, which has the dual ECUs. Important if we're going to get ASTM certified to do ELSA and SLSA aircraft. And there, as I mentioned, on the pilot side of the firewall, they do need to be kept cool. For reference, these are mounted just under the 20-gallon fuel tank. So you will be able to reach them, but they're up out of the way of the rudder pedals, and the wire harnesses there are out of the way of the pedals as well. The brown wires that you see there, those are just sloppily thrown in there. They're passing through the firewall, but the pilot side of the cabin side isn't routed yet. Those are the EGT and CHT probe wires. And you can see you kind of see the big circle in the firewall in the picture on the left. And then in the upper right there, you can see the stainless cover, if you will, for the cable pass-throughs. Now, UL Power gives you all of these harnesses with these very big Cannon plugs pre-wired. So you obviously don't want to undo any of that wiring. And they don't make, like bulkhead connections for the firewall with an extra wiring harness, which would be a lot of wire and a lot of extra weight. So we just cut a big hole big enough to pass the two Cannon plugs through. And we made this two-piece cover plate out of stainless. And you can see there we've got some fire sleeve that's treated in RTB. We do have to split it down the middle to make a seam in order, again, to get around the pre-wired harness. We will, when we tidy all this up, we'll glue those seams together and put some wraps around them so that they go fully around the cable, the cable bundles, and of course we'll be squeezing our RTV in on both ends to make it a true firewall pass through. So that'll be something that we'll have for UL Power installations in the future as a product, sort of these two stainless pieces that you'll be able to get from Sonex in the future. And you can see on the right there, we've test fit a cowling. Now that is not the cowling for this airplane. It's a cowling actually for Chris Nash's Sonex, his personal Sonex that he happened to have off the airplane. So we stole it for a few minutes just to do a quick test fit. And you can see the engine in there. Of course, we'll be working on the baffle fitting and the openings and all that sort of stuff. You'll notice there the prop hub spacer is right where we want it in the cowling. If you're doing a UL Power, 4-cylinder UL Power engine on any of the Sonex, YX, or Xenos aircraft, you'll need the 110 millimeter prop hub extension to get it to fit in the cowling correctly and get the props set where it goes using our engine mounts. And then avionics installation. So Dynon is working with us on another system. We currently have their HCX system in our AeroV turbo powered B model tri-gear Sonex. And we're liking it quite a bit. We had some growing pains with it just in terms of how we installed it. We were not 100% happy with where we have all the boxes and everything. One of the innovations that I was really excited about when Dynon came out with it is their tray system, which you can see in the rendering on the right. These are actually CAD renderings from Dynon, from Dave Weber, of course, who is a Sonex builder and Dynon employee. So we got an in there at Dynon. And you can see the trays. So the trays are meant to be able to slide out through the instrument hole, and all of the exterior boxes can stack inside the tray behind the displays. So it's really a great improvement, I feel, in the Dynon system for getting all of the accessories installed in a nice, tidy way with as low of a weight as possible. So we're excited to get that installation. Dave is actually going to be coming out to our facility, I think in late February, helping us to install this system. And that's when things will start getting really exciting in terms of finishing this airplane up and getting ready to fly it. All right, so what's next? So obviously we have to complete the outboard wings. That's in process. Complete installation of the controls. We have a machined aluminum bell crank at the front of the aileron torque tube in the center console that we have to get from our machinist yet. A couple more push rods from the welder that we have to get yet, and we'll get all of that controls installation completed. Obviously finalize those stick assemblies that I showed you. We have to complete the firewall forward installation, which is well on the way. Avionics installation, the last 10% that takes 90% of the time, right? All the detail stuff. And then the cowling installation, windows and the doors and skylights and everything, and all of our fairings, our push rod and cable fairings, the fairings at the root of the wing, at the trailing edge of the wing, which I didn't talk about here, but we are working on. So our goal for first flight, I know this is dangerous, the answer should be Tuesday, right? Well, you don't say what Tuesday. I'm going to say March or April. And although I didn't print it here, I'm saying March or April 2025. So we really want to get this flying as early as we can this spring and get this airplane out there to people. It's really in demand, it seems like. Deposits. A lot of people have asked me about kit reservation deposits, which we haven't started accepting yet. Telling you, breaking news, we are going to start accepting $500 reservation deposits to get yourself in line. It helps us tremendously in terms of, planning inventory and that sort of thing. Look for that maybe next week, probably when we publish sort of a website version of this update and the archive video of this webinar. So with that, Charlie, with 6 minutes remaining, I'll open it up to questions.
All right, let's go to lightning round. Andrew, are the flaps to be electric, manual, or builder option?
So we will be doing them electric, just like they are in the B models. The nice thing is we've designed this flap system with a shorter but yet more powerful actuator, so they'll deploy a little bit quicker. Builder option, if you really want a flap handle, it's definitely possible. We didn't want to clutter up the ceiling of the cockpit, especially with the aileron controls where they are. But if I'm not planning to do it unless millions of people tell me that they want it. But if a one-off builder wanted to do it, it's definitely doable.
Okay, are the aux tanks also going to be the rotationally molded plastic?
Yes, they are.
Okay. Let's see here. Trying to get a few more in here. Paul asks, can the high wing be equipped with amphibious floats?
Yes, absolutely. If you're not familiar with the history going back many years now of Sonex, we actually put amphibious floats on a Sonex, on an original A model Sonex with a Jabiru 3300 engine. We put Czech Airworks amphib floats. They're now branded as Zen Air floats, and the airplane flew great. The big thing was not many people wanted a low wing float plane. And also the insurance bill, especially for amphibs, is quite high. But the high wing's great, very well suited to floats or even skis. And so that's going to be very doable. And I'm actually excited about when we get to that point in terms of helping people to do those installations when the time comes.
Yeah, low wings and docks aren't really a great thing. Paul asks,
unless you're going for the Thompson Trophy.
Yeah, Paul asks, will the left and right cockpit doors accommodate observer windows?
Yeah, I mean, certainly we could throw a piece of plexiglass in the oven and blow a bubble and make bubbled out windows. I've had a lot of people ask me about bubble doors, like all plexiglass bubble doors. You know, I'm sure, again, like floats, it's one of those things we'll probably get to if enough people ask for it, or if a builder wanted to do it on their own, it would be very easy to do. A door, like a bubble door, for instance, you know, makes it hard to make the door rigid. That would probably require a chromoly steel welded door frame just out of, you know, very small diameter tubing. Definitely doable. Not really the spirit and intent of the airplane, but I know people are going to want to do it, just like I know people are going to want to put big Tundra tires on it, even though that's not what we really designed it for.
Okay, that knocks out another question. Uh, Paul asks, will there be a YX version of the Sonex High Wing?
No, there will not. And you can see I covered this on previous webinars and updates. Basically, the wash of the wing in a high wing configuration is too turbulent for a wide tail. So we did examine that and we found it to be not feasible.
All right, and are you going to make autopilot available?
Yes, certainly. Just like the current airplanes, you can do autopilot servos in, you know, for Dynon, Garmin, MGL. You know, we'll be working certainly with Dynon on more autopilot installation specifics. We're not planning to put it in this airplane, at least not yet. Maybe we'll convert it later. But again, extremely doable and something you can get support for when the time comes.
All right, Mark, well, we're about out of time. Let's close it out with some last thoughts.
Boy, yeah. Thank you, everyone. Again, Charlie, what was our final head count today?
Oh, yeah, John asked about that, over 400. So great
Beautiful.
turnout. Thank you.
Wonderful, great turnout, and I thank all of you for tuning in, and I thank your bosses if you're at work sneaking this webinar. I appreciate the enthusiastic support that we've gotten from people. It seems to me that people really want this airplane, which is just so gratifying for me as the designer, and you know, for us in terms of you know, being able to do this and get this prototype done. It's great motivation. And yeah, join our mailing list if you haven't already. You can see the web address up there, sonexaircraft.com/Hornets Nest High Wing. A little bit, you have to type the underscore in the dashes, but there you go. Or just shoot me an email, sales@sonexaircraft.com, and I'll send you a link to it or add you to the mailing list myself. And of course, feel free to call and email with any questions. Watch our website and our mailing list for sort of a website published version of this update, including the opening up of reservation deposits so you can get in line.
All right, well, thank you, Mark. Thanks, everybody, for tuning in. Up next, we have Garmin Experimental Avionics Solutions. So thanks, everybody.